Good morning, students. In the last class, we have studied about an optical phenomenon, that is mirage, and it takes place on account of refraction of light. We have even studied various examples of atmospheric refraction of light, like we have studied about why stars twinkle and what is the apparent position of the stars, and early or advanced sunrise and delayed sunset, why planets do not twinkle, what makes us feel the presence of water at a certain distance on extremely heated tar roads in summers, and why do objects flicker beyond the fire. So all these are examples of atmospheric refraction that we experience in our life. Today we are studying another topic, and that is partial and total internal reflection. Let us try to understand what it is. When a ray of light travels from denser medium to a rarer medium, it gets partially reflected. That is, part of the light gets reflected and comes back into denser medium as per laws of reflection. Now let us try to understand this statement. Now partial or total internal reflection will take place when a ray of light is going from the denser medium to a rarer medium. This is the very first point that you have to remember. That is, the ray is going to travel from denser medium into rarer medium. So when a ray of light travels from denser to the rarer medium, some part of the light gets reflected back and it travels back into the denser medium. So since only some part of the light is getting reflected back, it is said to be partial reflection. So some part of the light gets reflected and comes back into the denser medium as per laws of reflection. So laws of reflection you have studied, that is the incident ray, the reflected ray, and the normal at the point of incidence. All three lie in the same plane, and incident angle and the angle of reflection are same. So these laws are followed here, and we find that some part of the light gets reflected back and it travels back into the denser medium. This is called partial reflection. The rest of the light gets refracted and goes into the rarer medium. So only some part of the light is getting reflected and it comes back into the denser medium, but most of the light goes into the rarer medium, thereby bringing about refraction of light. As light is going from denser to rarer medium, it bends away from the normal. That is, the angle of incidence I is smaller than the angle of refraction R. So this is also what we have studied. Since the light ray is traveling from the denser medium and it is going into rarer medium, and so the ray of light will go away from the normal. The refracted ray will go away from the normal, and this is because the speed of light will increase when it goes into the rarer medium, and so it goes or it bends away from the normal. So in that case, the angle of incidence, that is I, which will be in the denser medium, is smaller than the angle of refraction, that is R, in the rarer medium. So angle I will be smaller as compared to angle of refraction, that is R. Now the same thing we will try to understand with the help of a diagram. So let's go to the next slide. Let us try to understand partial and total internal reflection with the help of this diagram here. In this diagram, you have this interface, the one which separates the two mediums from one another. Here you have medium 1, this is medium 2. Medium 1 is air, medium 2 is water. Here is the source of light has been given from where the rays of light are traveling from the denser medium into the rarer medium. Now let us take up the incident rays one by one. You have been shown 4 incident rays, 1, 2, 3 and 4. Now we will take one ray at a time and try to understand this. Now the first ray, here this is the incident ray, this is the refracted ray. So a ray of light that is traveling is from the denser medium and going into rarer medium. Here this is the normal, and the ray of light is going away from the normal. We can see this because the speed of light is increasing. This is your angle of incidence. This is your angle of refraction. But as we studied earlier, that some part of the light gets reflected back into the denser medium. So here we have some part of light getting reflected back into denser medium. So here you have this angle to be the angle of reflection. Let us take up the second ray. This is the second ray, incident ray of light. We find that this angle of incidence is greater than this angle of incidence. So you are increasing the angle of incidence. So if you increase the angle of incidence, the angle of refraction will also increase. Here you can see that this angle of refraction is greater than what you had here. So as you increase the angle of incidence, the angle of refraction will also increase. Now why will it increase? If we increase I, R will also increase according to Snell's law, as the refractive index is constant. So we have studied that the refractive index, that is the ratio of sin I upon sin R for a given pair of media, is constant, and hence you will find that if you increase the angle of incidence, the angle of refraction will also increase. So here also you can see that once the ray of light travels from denser medium and goes into the rarer medium, it goes away from the normal. But again you find that some part of light gets reflected back into the denser medium, and this is called as partial reflection. Now if we take the third ray here, we find that the angle of incidence has increased still further. But for this particular angle of incidence, the angle of refraction has become 90 degrees. So you can see this line over here. It is forming a 90-degree angle with the normal. So for a certain value of angle of incidence, the angle of refraction becomes 90 degrees. So this particular angle of incidence for which your angle of refraction becomes 90 degrees is called as critical angle. So here we have angle of incidence for which the angle of refraction becomes 90 degrees is called critical angle. So this is the critical angle. Now if you increase the value of angle of incidence beyond the critical angle, now here you have this fourth ray, this is your angle of incidence, and this angle of incidence is greater than the critical angle. So here you have I is greater than IC. What does that mean? When the value of angle I becomes more than the angle of angle IC, that is the critical angle. So here you find that the angle of incidence has become greater than the critical angle value. In that case, what will happen? No ray will go into the rarer medium, but all of the light rays will get reflected back into the denser medium, and this phenomenon will be called as total internal reflection. So when I just repeat the two things, that is, for a certain value of angle of incidence, the angle of refraction becomes 90 degrees. So this value of angle of incidence for which your angle of refraction becomes 90 degrees is called as critical angle. And if you exceed the critical angle value, if the angle of incidence is more than the critical angle, in that case total internal reflection takes place and all of the light gets reflected back into the denser medium. So I hope you have understood this total and partial internal reflection. Here we have a small part here that we will take up. This is refractive index of first medium with respect to second medium, that is sin I upon sin r, where you have I to be the critical angle, and you know that the R here is 90 degrees, here this one. So angle of refraction is 90 degrees. So refractive index of first medium with respect to second medium will be given as sin I upon sin 90, because you have the value of angle of refraction to be 90 degrees. So sin 90. But what is the value of sin 90? Sin 90 is 1. So you will have a refractive index of first medium with respect to second medium is equal to sin I. Let us take up an example of this. If we have glass as our denser medium and air as rarer medium, in that case, we find that the critical angle value is 42 degrees. Means if the ray of light is traveling from glass to air, in that case, if the angle of incidence is 42 degrees, we will find that the angle of refraction becomes 90 degrees. So the critical angle for glass is 42 degrees. And if you exceed the value of critical angle, that is 42 degrees, then you find that total internal reflection takes place. So this was just one example of total internal reflection, and for glass the value of critical angle is 42 degrees.